We started off class today going more in depth with composite functions. We looked at composite functions in a string of three. You guys made up your own composite function problems. We looked at composite functions with variables, coming up with the final answer in terms of a variable x. And then now we're going to move on to a completely different type of function, which is an inverse function. Different but related. So on page 3 of your handout is where these notes will begin. And the definition of inverse function written here, it's a function where the inputs and the outputs switch places. Normally, a inverse function will be written with this type of notation. So you'll see f and then a little -1 x. And what this is telling you is that you're looking for or trying to find an inverse function. Okay, so what does it mean for the inputs and the outputs to switch places? A good thing to remind ourselves here might be the definition of inputs and outputs. So inputs are going to be our x variables, outputs are going to be our y variables. So as we're doing this, we always want to think about x and y, inputs and outputs, are switching places. They're replacing one another. So, example 1, find the inverse function of f of x equals 4x plus 3. So, I know I'm going to be trying to find an inverse function. So I know my x and my y, or my inputs and my outputs, are going to switch places. But a little bit confusing because I can see that I have an x here, so it's pretty clear that this is my input. And I can see this f of x over here is going to be my output. We also know y is the same thing as f of x. So sometimes our output is represented by y, sometimes output is represented by f of x. Okay, what I normally do as my first step in these types of problems is I replace f of x with y. So I'm just going to rewrite the same equation, but I'm just going to write y equals 4x plus 3. So using our two-column structure here, the first step I did was replace f of x with y. Why did I do that? Well, because it's just going to make the next step easier, because I'm going to switch places with x and y. So now, to find the inverse function, we're going to switch x and y. If this word switch is weird to you, as some other things you could think of, you're flipping x and y, you're replacing x and y, whatever verb works for you here. So what that's going to look like is the x goes where the y was, and the y goes where the x was. Okay, so let's make sure we keep track of x was here, it moved to the place of y was over here, and it moved to the place of x. Okay, so this is actually it. We have our inverse function. This is our inverse function. It's an equation that relates x and y. Normally the last step, and what we're always going to do in this class, is we're going to solve for equation in terms of y, meaning we're just going to get y by itself on one side of the equation. That's just kind of, in math, it looks better to have y by itself on one side of the equation. So how am I going to isolate y? I'm going to just subtract 3 to start. So now I have x minus 3 equals 4y. And then my very last step to isolate y would be to divide both sides by 4. So I end up with y equals x minus 3 over 4 as my final answer. We're normally used to seeing y on the left side of the equation, so I might just do that for my final answer. So I ran out of room, but over here I might write y equals x minus 3 over 4. And that is my inverse function that I just found. So I'd say this is kind of a 3-step problem. All right, the very last thing I might do just to make the next more complex problems easier is instead of y here, I might go back and replace this y with the f of x. So just like I did at the beginning, I might switch it back. But this time, instead of just writing f of x, I'm going to write the inverse of f of x. So using that little -1 here to indicate that it's an inverse function, equals x minus 3 over 4. So these would both be acceptable ways to write the final answer. And my output y means the same thing as this, inverse of f of x. Okay, so next problem. Okay, so now I see the little -1, this superscript of -1, telling me that I'm going to be doing something with an inverse function. So it's saying f of 2, the inverse of f of 2, for f of x equals 1 over x minus 3. So immediately, because I see that superscript, that -1, I know I'm going to be finding some sort of inverse function. And I know my definition of inverse function is I'm going to be flipping my x and my y, or switching my inputs and my outputs. So let's actually start with this equation here that I'm given. I'm going to find the inverse of this function, and then I'm going to plug in 2 as my input, but I'm going to plug it in as my input into my inverse function. Okay, so first step is going to be replace f of x with y. So I'm going to get y equals 1 over x minus 3. Switch x and y. X equals 1 over y minus 3. Solve for y. Another way to think of this could be isolate y. I use that word as well. And this is going to be a little bit harder to isolate y because I have y underneath a fraction in the denominator. A good thing to remember is to get rid of a denominator like this. You can always just multiply. The reason I wanted to do this is because this times this is just going to cancel out. The denominator cancels out with this, what it's being multiplied by. So I can get rid of that. But then whatever I do to one side, I have to also do to the other, which is why I also multiplied the y minus 3 over here. And then I can just distribute my x. So I'm going to get xy minus 3x equals 1. Okay, I'm not done isolating y yet. I'm going to have to add 3x to both sides. And then I end up with xy equals 1 plus 3x. And then my final step to isolate y, to get it all by itself, is to divide both sides by x. So my final inverse function, y equals 1 plus 3x over x. So over here, let me label that I found my inverse function. Okay. So once you have your inverse function, I want you to go back up to what we're trying to do in example 2. Think about how you could evaluate the inverse function for the input of 2. now that you have the inverse function. So one thing I might do just to notation-wise is replace y with f, the inverse of f of x. So I might just rewrite it as, this is my inverse function over x. And now what I'm trying to do, let me just bring this down. So what did I do? I replaced y with the inverse of f of x. And then now I'm going to evaluate the inverse function for the input of 2. So this means 2 is my input, meaning I can just do what we are used to doing, which is every time I see an x, I'm going to replace it with a 2. Okay, so to evaluate the inverse function at the input of 2, I'm going to get 1 plus 3 times 2 all over 2. Let's simplify that. 1 plus 6 over 2. And I'm going to end up with my final answer. The inverse function at the input of 2 is equal to 7 over 2. I'm going to leave my answer as a fraction. If you'd like to divide this and get it as a decimal, be my guest. I'm going to leave it like that. Okay, so example 1, we found the inverse function. Example 2, we went a little bit farther and we then we plugged in a specific input value and then used the inverse function to evaluate that input value. What we're going to do now is you have 3 problems to try. These problems are all going to involve finding the inverse function, and in some cases you're going to plug an input into the inverse function after you found it. You might want to complete these problems in your notebook just so you have notes, as well as just have more space to complete these problems. If you finish early, you can move on to your Delta Math assignment. It's called 2.5 inverse functions. All right, good luck.